This is section 3.6, page 2. We are doing some more chain rule examples. And here's the first one. G of x is sine squared x. Find g prime. The first thing that I would suggest you do is rewrite this sine squared as sine x quantity squared. Now you can absolutely see the outside exponent is 2. And when we do this derivative then, g prime, we can pull that 2 down in front, leave the inside alone to the first power, now times the derivative of the inside, and the derivative of that sine is cosine. And we have 2 sine x cosine x, which you should recognize as sine 2x. The next one here, notice the difference. This is sine x squared. It may be helpful for you on this one to write the sine of x squared and to put that x squared in parentheses, because then we can definitely see that the outside function is sine and the inside most function is x squared. And when we find that derivative, we start on the outside and work our way in. The derivative of sine is cosine. We'll leave the inside alone, times the derivative of the x squared, which is 2x. Now keep in mind, we can't multiply this 2x times that x squared because the x squared is on the inside of cosine and the 2x is not. So we'll just pull this 2x around front to remove that ambiguity there. There's that derivative. Done. Looking at this next one, d dx of secant 3x squared plus 1. Excuse me. Find the derivative. The derivative of secant x is secant x tangent x. So when we do the derivative of secant of this something, it's going to be secant of that something tangent of that something Sorry, I tried to pause it, but I couldn't pause it, and I don't want to restart the video, so you're just going to have to go with it. And then times the derivative of the inside, so that's 6x. Cleaning this up a bit, let's just take this 6x and pull that around front. 6x times the secant of 3x squared plus 1 times the tangent of 3x squared plus 1. And nothing simplifies here. You are good to go right there. That's it. This one, though, tad bit messier. Again, the first thing that I would suggest you do is rewrite this as 2 sine x quantity cubed times cosine x quantity squared. We are finding the derivative of that mess. All right, this is a product rule, quotient rule combination. Here's the first function and second function. So when we start our product rule, first, 2 times sine x cubed, it's the first, times the derivative of the second. Right now, there's a chain rule here with this second. So pull that 2 down in front, cosine x to the first, times the derivative of the cosine which is negative sine x. Be careful here, you remember it's times negative sine x, not minus sine x. So that was first times the derivative of the second, plus the second, cosine x squared, times the derivative of the first. Okay, derivative here, pull that 3 down, that's going to be a 6 sine x quantity squared, then times the derivative of the sine, which is cosine. Did I run off the page there? Okay, let's clean this up a bit. So that's all the derivative part. Looking at the rest of this, the coefficients, we have 2 times a negative 1, that's a negative 4. We have sine cubed here and another sine, that's going to be a sine to the 4th, and a cosine x. From the second part over here, coefficient, we have a 6 sine squared and cosine cubed. Oh, let's factor and see if we can get something to simplify out here. We could pull out a negative 2 sine squared cosine, and that's going to leave us with 2 sine squared minus 3 cosine squared. And, oh, sadly, nothing simplifies. The 2's and 3's, if those weren't there, then we could maybe do something with sine squared minus cosine squared, but nothing happens here. So, oops, we are done right there. That was it. There's your derivative. Okay, let's come down here and look at this one. F of x is cosecant of 4x. Find f prime. The derivative of cosecant is negative cosecant cotangent. Now, you gotta be careful when I say that, I don't say the argument, but it's there. F prime, but we have to start on the outside, do the derivative of cosecant, which is negative cosecant cotangent times the derivative of the inside, which is 4, and then just clean this up and pull that 4 around front. Negative 4 cosecant 4x cotangent 4x. That's it. Done. Isn't that nice? All right. This one's a doozy over here. We have this outside exponent, this cube. So when you've got these exponents on the trig functions, your best bet is to always rewrite that so that you see that outside exponent. So when I rewrite this, we'll have the cosine of 4x squared plus 3. All right, now the cosine's the thing that's cubed. So it looks like that. And when you look at this, I need you to see that that is 3 nested functions. Cubic on the outside. The next layer in is the cosine, and the next layer in is this quadratic. So there are 3 functions here, and we'll have to do a chain rule starting on the outside and work our way in. So it's a double chain rule. F prime then. All right, we start on the outsidemost function. The outsidemost function is this cubic. So do a derivative on a cubic. This 3 comes down in front. Inside stays the same, and that 3 up here turns to a 2. So we'll have 3 cosine 4x squared plus 3 squared times, so we did the cubic. Now let's do the derivative of the next layer in, and the next layer in is cosine. The derivative of cosine is negative sine. Its inside stays the same. Okay, so we've done the derivative of the cubic, the derivative of the cosine, and all that's left then is to multiply times the derivative of the inside most, which is the derivative of 4x squared plus 3, or 8x. All right, cleaning this up. Everything's being multiplied here. So I have a 3 for a coefficient, a 3, a -1, oh, and this 8, and then x. So how about negative 24x? We have cosine squared of 4x squared plus 3, and a sine of 4x squared plus 3. Yikes. So that was 3 nested functions, and we had 2 chain rules to do. Thank you very much. Please check out page 3.